Hi, welcome back to this YouTube channel. My name is Anubhav and today I'm going to cover scalable design of next generation firewall. This design is also known as Azure Load Balancer Sandwich Design. So I have decided to create this video in such a way that initially I will talk about this particular design. I will give you deep dive information on how this design is deployed, what kind of next generation firewall is available in marketplace, how you will add it behind load balancer to make your design more scalable. Then I will talk about traffic flow, north, south, east, west, and I will also talk about different kind of probes that you will configure to check availability of your firewalls. And then I have something on traffic separation as well. I received a request from multiple customers to separate internet traffic with east-west traffic, so I have few slides on that as well. And in the end I have a live demo. It is going to be a pretty big demo because I'm going to deploy everything from scratch. I will deploy resource group, virtual network, firewalls, UDR. If you are not sure about what these components are, don't worry, I will be covering most of the components during the demo. Let me start off with next generation firewall in Azure. So today we have next generation firewall or firepower threat defense available in marketplace of Azure. You can deploy it in routed mode. Using this virtual appliance, we provide features like networking. You can use it for routing your traffic, firewalling, threat-centric protection, which is our next generation IPS offering. You can also enable URL filtering. We have AMP capabilities. Using this virtual appliance, you can provide network AMP services for any kind of traffic that is flowing in your virtual network. For managing this particular virtual appliance, you require Firepower Management Center, which is outside of Azure right now. So you can either manage it using virtual FMC or you can use physical FMC as well. On number of interfaces, we have 4 interfaces right now, starting from ETH0 till ETH3. First 2 interfaces are for management and other 2 interfaces are your data interfaces. We have this device on D3 and D3v2 instances. So if you go to marketplace, you will find next generation firewall instances on standard D3 and standard D3v2. We also have ASAV instances. If your use case is VPN concentrator and classical firewall function, you can use ASAV as well. But if you are looking for threat-centric protection, we would suggest you to go with next generation firewall. We also integrate with Umbrella, ICE, and in future we are also coming up with other security offerings which are there already. We will integrate with those technologies as well. So before I talk about anything on how everything will work in Azure, let me step back and talk to you a little bit about Azure UDR or user defined routes. So now imagine you have your firewall in your network. You have a 3-tier architecture, web, app, and database. Now you want to place your firewall in such a way that traffic should go to your firewall and your firewall should act as a next hop. So in Azure, you have a flexibility of creating your own user defined route table. Inside that route table, you can add routes. Now, if you look at this particular diagram here, I have a web UDR, which I have associated to my web subnet. In that UDR, if you look at next hop or a default route, it is ASAV inside interface. It can be next generation firewalls inside interface as well. And you can add more specific routes as well. So any traffic leaving your virtual NIC of your VM, that traffic is forwarded based on routes in the UDR. So this route takes precedence over system route and it is associated to a subnet. In the next hop option, there are multiple options available. You need to use virtual appliance where you can point your traffic to next generation firewall or ASA. If you want to block whole traffic, you can use none. If you want to send your traffic directly to internet, you can use internet as your next hop. If you want to send it to virtual network gateway, which is Azure's VPN device, you can use that as a next hop. If you want to make sure that traffic stays internal, you can use vNET as your next hop. UDR can be modified using API calls, and we have used this feature while designing our ASAV HA solution, but this video is based on how to scale out. Rather than having active and standby device, you can have multiple devices processing traffic simultaneously. So now if you look at this particular example, I have a firewall at the edge, I have users on the internet, and I have external and internal interfaces on my firewall. I'm managing my firewalls using Firepower Management Center in my data center, which is there in my data center, through my express route. So express route is your connectivity from your data center to your cloud provider. So you can use that route. You can also use your public route as well using the public IP address, but in this case I'm just managing through my express route. And apart from that, I have a web app and database subnets. Now I can control traffic based on UDRs. I can go ahead and add routes in my UDR and specify that next hop is going to be firewall. So if you look at my routes, next hop is always the next generation firewalls inside interface. So that will send traffic to firewall. On firewall, I will process traffic. If traffic is allowed, I will hairpin that traffic back to the same interface and send it to the destination subnet. Now, if you want to enable microsegmentation, you can add a self subnet route as well. That will ensure if that any VM talking to another VM within the same subnet, that traffic will also go to firewall for further inspection. This is another route table that I have added. You can also control traffic coming from your data center. So any traffic coming from your data center or going to your data center, that can also be filtered by this virtual appliance. You just need to add that route in your route table, which is associated to your gateway subnet. Now, what is the problem with that particular model? That model was only restricted to one appliance. Now let's take an example where you have requirement for more throughput. What would you do is you will opt for a scalable design where you can have multiple firewalls between two load balancer, external and internal load balancers. Now if you look at this particular example, I have all the firewalls in availability set. When I deploy firewalls in availability set, Azure will make sure that all firewalls are on different set of hardware. So if they run any kind of hardware maintenance or if they run into any kind of outage, all your virtual appliances are not affected. Now in this example, I have external load balancer facing external interfaces of my firewall, internal load balancer facing internal interface of my firewall. So this is kind of a sandwich design where firewalls are there in the middle of two load balancers, and I'm controlling traffic based on UDR. Now if you look at UDR, a next hop is 1082.3.100. Now what is this IP address? This IP address is virtual IP address of my internal load balancer. So I'm going to send all the traffic to internal load balancer. Internal load balancer will send it to firewall, and then it will go to destination subnet. Internal load balancer is also smart enough to track state of the traffic, or it can maintain symmetry. So it knows where the initial packet went. It will send the return packets to the same firewall. On the other side, from when you are coming from internet, external load balancer is going to take care of your traffic. Users will initiate traffic to front-end IP address, which is there on the load balancer. Traffic is then load balanced across all the VMs. Now let's talk about traffic flow in detail. Now if you look at inbound traffic flow, it is really important. Users from internet will come and access your VMs from internet. So traffic will land up on your external load balancer. External load balancer will calculate 5-tuple load balancing and forward it to one of the firewalls. The moment we receive traffic on firewall, we translate source to egress interface. In this case, we will translate it to internal interface. Intention of this translation is to bring back traffic back to the same firewall, because there is no way to maintain symmetry. So for north-south traffic, we definitely need source NAT. Another kind of traffic flow is outbound traffic flow. So now outbound traffic flow is really required when you have your application servers or your servers in your network which requires any kind of package download or Windows update downloads from internet. Then you can use UDR, and based on UDR, traffic will go to internal load balancer. Internal load balancer will send it to firewall. Firewall will receive it, and on firewall we change the source of the traffic to egress interface and send it to internet using external load balancer. This is really a basic design. If you look at external load balancer, there is a limitation with this particular traffic flow. External load balancer can only handle traffic for which it has load balancing rule. For example, on load balancer you have load balancing rule for port 80, port 443. Then your outbound traffic can be only on these two ports. If you're using any unknown port, external load balancer will drop that particular traffic. So there is another kind of load balance, the outbound traffic flow, where what you will do is you will map public IP addresses directly to your firewall's external interface. So your external interface will still have private IP address, but on the Azure NAT gateway there is a mapping. So you will add a public IP address to your firewall. So whenever there is outbound flow, traffic will be forwarded to firewall, and this time firewall will translate it to external interface, and instead of sending it to external load balancer, traffic will straight away go to internet. So here you are not restricted on your load balancing rules. So any traffic that is coming from inside will definitely go to firewall. Firewall will forward it to internet directly rather than sending it to external load balancer. Now let's talk about east-west traffic inspection. So east-west traffic inspection is exactly same. You have UDR. UDR is going to control traffic. Traffic will come to internal load balancer, then to firewall, then to the destination subnet. Now on the way back, there is another UDR which is applied on the destination subnet as well, which will force that traffic back to internal load balancer. Now internal load balancer will look at state table and forward it back to the same firewall. So in this particular case, for east-west traffic, you do not need any kind of source NAT. Another important traffic flow is when your traffic is coming from your data center or it is going to your data center. In that particular case, you have your express route. So if you have your express route connectivity, you will be placing your virtual network gateway in gateway subnet. Now on the gateway subnet, you can add a route table and you can specify destination. If destination is application, app, or database subnet, send it to internal load balancer, and then same traffic flow will happen. It will come through the same load balancer and same firewall. Now let's talk about NSG and source NAT. I have already talked about source NAT in detail. Just to rephrase, if your traffic is outbound, we source NAT it to outside interface. If traffic is inbound, we translate source to inbound interface or inside interface. Now there is a mandatory requirement from Azure. If you're using standard load balancer, make sure that you have NSG applied to the interface. If you don't have NSG applied to the interface, your traffic is going to be dropped by default. So if you are using load balancer sandwich design with standard IPs and standard load balancer, ensure that you have NSG applied to all interfaces. Now in this particular example, I have NSG applied to inside interface, NSG applied to outside interface, and I'm allowing all the traffic in NSG and controlling everything from my next generation firewall. I can go and allow traffic in NSG and then on the next generation firewall as well, but that will not give me complete visibility. So what we recommend in this situation is allow everything in NSG, let the firewall process that traffic, and so that you will get complete visibility. But if your security policies or your InfoSec policy says that you should have traffic blocked at the NSG layer, that is not a problem. You can allow that traffic in NSG and then on firewall. So as long as firewall is receiving traffic, we can process it. We will show you all the events and logs, and we'll process that traffic. Now probes are really important to understand, because load balancers will probe your firewall and for the existence. If firewall is not available for a certain amount of time, that a firewall is removed from the backend pool. So there are different mechanisms that you can use. So I'll talk about probe firewall. So in this particular method, you can enable TCP/22 on interfaces and probe interfaces. So you are just probing your directly connected interfaces. Second kind of probe is you can probe through the firewall. It requires NAT and route configuration on the firewall, but it is reliable probe. You are probing your firewall through the firewall traffic as well. So you are ensuring that all the components of the firewall and even the far side interface of the firewall is up and running or not. Third one is a probe application port. So instead of adding probe ports and doing a lot of configuration there, you can also probe your application ports, because if you will have your application server on the other side of the firewall, you will definitely create your NAT and access control policy. You can use those same NAT and configuration policies to send your probe traffic as well. So this is how what we do on the probe side. If you look at this particular example, external load balancer is just probing external interfaces, internal load balancer is probing internal interfaces. So we are not probing far side interface. So in this particular design, if anything happens to the far side interface, internal load balancer will definitely forward traffic, because internal load balancer is only probing internal interfaces. It will not know anything about external interface. So this is a probe where you think that you can go with this particular design. It's really easy to configure. You can still go with this. But if you are looking for more reliable probes, we will suggest you to either use application port probes or through the firewall probes. Both are through the firewalls. It will ensure that your egress and ingress interfaces are up and your complete firewall stack is up. Now if you look at this example, what we generally do is we track any traffic coming from 186.63.129.16 IP address, which is IP address of your load balancer, and any traffic hitting on inside interface on port 22, we will send it to outside interface, and while sending it on the other side, we translate source into outside interface and translate destination to management IP address. So we don't want to rely on any kind of other or a third VM on the other side. So instead of tracking third interface, we are just tracking firewall itself. So traffic will come to firewall, will change source to outside and destination to management, and we probe our management IP address. So this kind of configuration is really reliable. You can ensure that your internal interface is up, external interface is up, firewall stack is up. Similar kind of probe is available for external load balancer as well. So here we send traffic to outside interface on port 22, then to inside interface. We source LAN translate our packet to inside interface, and destination is translated to management IP. Again, we are catching traffic from IP address of that load balancer, which is 168.63.129.16. Okay, so we are using different metrics in the route table so that we can pick the right interface. So I'll talk about that when I will show you end-to-end demo. So I'll talk about NAT and access control policy and route configuration there. Now, third kind of probe is your application traffic probe. So you have your external load balancer. Instead of probing firewalls, we are probing our web servers directly. So firewalls are added in the backend pool. So as soon as traffic is landed on the firewall, it landed on the load balancer, it will go to firewalls definitely. But this forwarding will happen only if our probes are up. So instead of probing firewalls, we are probing something which is on the other side of the firewall. So each load balancing rule will have its own probe. So I have web server 2 working on port 80 and web server 1 working on port 443. So I'll create 2 load balancing rules and I will attach 2 different probes, probe 1 to first traffic, probe to another traffic. So in case your web server 2 is not up, that traffic is going to be dropped. But if your web server 1 is up, your traffic will still go through both firewalls, because we are not probing firewalls, we are probing our application servers. Now on the traffic separation side, there was a customer where he had a requirement of segregating internet traffic. So you can have external load balancer, internal load balancer with 2 virtual IPs. First virtual IP will face towards internet firewall. Second virtual IP will face towards another set of firewall processing your east-west traffic. So now let's take a look at the traffic flow when you have multiple virtual IPs. Traffic from internet will land up on external load balancer. It will come to your firewall. From the firewall, it will go to the destination machine. On the outbound side, again, traffic will come to your UDR. UDR will send it to virtual IP 1, and from there it will go to internet, either through the external load balancer, or you can assign public IP address or map public IP address directly to your external interface, and then it will use that path as well. Now, if traffic is east-west, traffic will come to you for a UDR. UDR is going to forward that traffic to internal firewalls, and from there it will go to the destination subnet. If traffic is coming from data center, again, virtual IP2 is picked, and that load balancer virtual IP is facing your local firewalls or your internal firewalls. Traffic is processed by firewall 3 or firewall 4 because it is east-west traffic. Now, demo is really important. What I'll do is I'll just take couple of minutes to explain what I'm going to deploy in this demo. I'm going to start off from scratch. I will create a resource group. I will create availability set. I will create a virtual network, and inside of that virtual network, I will create multiple subnets. I will start off with management subnet. Then I will create diagnostic subnet, internal and external subnet. These 4 subnets are required to deploy firewalls. Apart from that, I will be deploying application subnet, web subnet, and database subnets. And I will also be creating UDRs to forward traffic to load balancers. And definitely I will show you deployment of internal load balancer, external load balancer, and how to add these firewalls in the backend pool. So in this demo, I will be covering these points. I will start off with creation of a resource group, then availability set, virtual network, and subnets. I will deploy firewalls using ARM templates. Then I will talk about and create NSGs and associate NSGs to firewall interfaces. This is really important because if you have your entire setup up and running but your NSGs are not applied, NSG will definitely go and block traffic. Your firewall will never receive any kind of traffic. Once I'm done with with the NSG configuration, I will create and configure internal load balancer and external load balancer. When I talk about load balancer, I'll configure probes, load balancing rules, front-end IP. So I'll show you end-to-end configuration of load balancers as well. Then I will deploy Windows machine in my web subnet so that I can show you traffic flow as well. I will create UDRs, web application database subnet UDRs. I will associate UDRs. I will add routes to the UDR, so you will get full understanding of how to attach UDR to a subnet, how to create routes, and do everything. Now, once my Azure portion is complete, I will log into my firewalls and I will show you configuration of interfaces, security zones, access control policies, NAT, route tables, and I will do all kind of configuration required for enabling probes. Remember, I showed you different types of probes. For this particular demo, I will be doing a through the firewall demo so that I can show you NAT and route configuration as well. And then once firewall configuration is done, we'll deploy configuration on both firewalls, and then we will verify probes on Azure portal. And if our probes are up, we will try to send traffic north-south traffic from internet. I will send traffic to external load balancer, and I will try to access my web server. And if my setup will not work, I will show you some kind of troubleshooting as well, because I have a plan of including few troubleshooting steps as well. So you can pause this video for now and take a deep breath and grab a cup of coffee, because this next 1 hour is going to be very important. If you miss any crucial step, your entire design will not work. So I'm going to definitely take around 1 hour to deploy everything from step to step. I don't want to rush, because I want to make sure that you understand each and every step. Its intention is to give you one long video file so that you can deploy all the components by just looking at that demo. So sit back and relax. We'll start at this demo in a couple of seconds. Welcome back. I'm now in my Azure portal, and I will show you how to deploy everything. So I'll start off with resource group. If you click on resource group and click create, here you need to enter your resource group name. So I'm going to use answami-rg, and I will put it in East US region. So once my resource group is created, I will deploy each and everything inside of my resource group. So I will go ahead and pin it, and then I'll click on create resources again, and I will now create availability set. So with availability set, Azure will make sure that your devices are deployed on separate hardware. So on this window, I just need to enter name and provide my resource group in which I'm putting my availability set. For fault domain, I'm just using 2 devices, so I'll leave it at 2, and then I'll click create. So by using this particular method, Azure will ensure that you have all your devices in separate hardware. In case if there is a failure of a device or any software maintenance on Azure side, all your firewalls are not impacted. So next step is to create virtual network, but you can see all your events from the bell icon. You can see whatever is deployed from here. So next step is to create virtual network. So I'm just going ahead and creating virtual network. I'm inside my virtual network now. I will click create. Here I will specify a lot of things like name of this vNet. So I'm going to use dash vNet as my name, and my CIDR range for this vNet is 10.82.00/16. I'm going to give my resource group my default network or first network in this vNet is going to be MGMT subnet, and my range for MGMT subnet is 0.0/24. I will hit create now. And once this is created, I will create subnets as well. So subnets are really important because in order to deploy this firewall, you at least need 4 subnets. I'll go back to my resource group and look at my virtual network. And if I click subnets, you will see that I only have 1 subnet at the moment. So I will go ahead and create multiple subnets. First subnet is management subnet, second subnet is diagnostic subnet. Then I will create external, internal, web, app, and database. So all these 5 subnets I will create for this particular demo. Remember, I'm placing multiple firewalls between 2 load balancers, and I have 3-tier architecture in my network. So intention is to create all the subnets and show you how exactly traffic will flow. So I have external subnet, internal subnet, management, diagnostics, and now I will create web, app, and database subnets. So these are few prerequisites for making this design to work. You just need to enter all the subnets that you want to deploy. You can even customize your cloud or your ARM templates in such a way that your ARM template can do all these settings for you as well. But for making this demo simpler and to show you all the steps step by step, I'm just deploying everything. Now if you will refresh and if you go back to your virtual network, you will see all those subnets there. Now once you have your availability set, your vNet, next step is to deploy firewall using ARM templates. I would be sharing this ARM template in description of this video. You can download it and you can use it in your network as well. So in this template, first step is to provide your resource group. It can be existing resource group or a new resource group as well, but this template is designed to work with existing resource group. Now I will define VM name for firewall 1, which is NGFWv02. Admin user, I'm going to use admin user and swami.admin, and I'm just giving password here. Now I need to specify my storage account, so I'll use str01 and str02. Next thing that I will specify is availability set resource group. So here I will specify my resource group. I'll specify name of my availability set, resource group for my virtual network, and then I'll specify name of my virtual network, which is answami-vnet. I have management subnet or first subnet, which is MGMT. I'm going to give IP address to that subnet, which is 10.82.0.10, and second device will get .11. I'm going to give name of my diagnostic interface, and I'm going to specify first IP, which is 1.10, second IP second interface IP on second firewall is .11. External subnet will have 2.10 as my first firewall, 2.11 as my second firewall. Same thing I will do for internal interface as well. Once you have all these settings configured or specified in your ARM template window, you need to click on I agree and then click on purchase. Make sure that you have provided all your inputs by giving the correct availability set name, correct interfaces, correct IPs, and correct availability set, and all the instances or all the attributes that we created prior to deploying the firewall using ARM template. You may ensure that all the attributes are correct. Now this process will take 5 to 8 minutes. You will see that firewalls are getting deployed, and once firewalls are deployed, you can access those firewalls using SSH. So this ARM template is going to check all the resource attributes and deploy your firewalls accordingly. Now once firewalls are deployed, you can click on your resource group and you can verify all your components. Now next step after deploying firewall is to create load balancers. We'll start off with load balancer. I'll go ahead and create internal load balancer first. So here I will give it a name, -ILB 01, and it is going to be type internal standard IP address. I will select my virtual network. When I select my virtual network, I need to specify my subnet as well. I'm going to place this load balancer in internal subnet. I'm going to give it a static IP address, which is 10.82.3.100, and I will be using this IP address in my UDRs, and I will specify my resource group as well, and I will click create. Again, creation of internal load balancer will again take a couple of minutes. Once it is created, we'll go inside internal load balancer and configure our internal load balancer as well. So I'm back inside my resource group and I have internal load balancer. If you look at this internal load balancer, I first need to start off with health probes. So I'll go ahead and create a probe. I'll give it a name. I will use port 22 as my probe port. Next thing that I will create is my backend pool. So in my backend pool, I'll specify interfaces of my firewall. Since this is internal load balancer, I'm going to specify internal interfaces of both firewalls as my backend pool. So I'll just give it a name, pool 1, and I'll specify my resource group. It will automatically show you number of VMs there, so you just need to pick from your list, and I'm going to use last interface, which is my internal interface of the device. So I will go ahead and click add. Once you will click add, Azure portal will add those two interfaces in the backend pool. Third step is to create load balancing rule. You just need to specify your name of the rule and HA port. We need HA port because we want any TCP and UDP traffic should be load balanced. We don't require any kind of load balancing rule, so we just go create a load balancing rule and use HA port functionality. This is a front-end IP address, which is 3.100. So any traffic coming to this IP address will be load balanced across these two firewalls, and these two firewalls are basically internal interfaces of the device. So any traffic for probe 22, if probes are up, any traffic on TCP and UDP will go back to the firewall's internal interfaces. Now let's work on creating external load balancer, which is again really important as the internal load balancer. So I'll go to the same place. I will click create. I'll click create load balancer. I'll specify name for this load balancer -ELB01, and I will use public standard load balancer, and I will use create new IP. So I will just specify name for this IP, and this IP is going to be front-end IP address for my external users. So I'm going to click validate and OK now. So again, this process will take approximately 1 to 2 minutes, and once it is deployed, you can then go back in your resource group and search for ELB, and you can configure your external load balancer in the same way as well. So now let's go ahead and click on add, and let's add probes. Here we are again using port 22 as my probe interface. Now I will click on backend pools and I will click on add pool 1. Here I will specify my resource group, and then again from the drop down menu I'm going to select both firewalls, but this time I'm going to use external interfaces of my firewalls. I'll click on add again. Now next step is to define load balancing rules. So HA port functionality is not available in external load balancer, so here you need to explicitly create your rules. So here for this particular demo I'm going to use port 80. So any traffic coming on port 80, if probes are up, that traffic is going to pool 1. And if you look at pool 1, what is pool 1? It is external interface of the firewall. So I have front-end IP address, I have backend pool, and this backend pool is pointing to external interfaces of both firewalls. I have probes on port 22. So this is how I have configured my external load balancer. It is pretty simple. There is nothing very difficult about it. Now next step is to create NSG or network security groups. Remember I told you that you need network security groups on your device. You can go ahead and create it. So in this example I'm creating a network security group, external and internal, and later on during the video I will attach these NSGs to firewalls as well. So I just need to specify resource group name and click OK. Once this NSG is created, I will go inside NSG and allow all traffic. So intention of allowing all the traffic is to get traffic on firewalls so that we have complete visibility on firewall rather than blocking everything on NSG or at the NSG level. You can still do that. You can still add your NSGs and rules inside your NSG and control traffic there, but that is going to be double work for you. If you want to allow any traffic, you will have to first go inside your NSG, allow it there, then on the firewall as well. And downside is if you are controlling traffic using NSG, you will not have complete visibility in your firepower management center because only filtered traffic will hit firepower management center. So this is what is suggested, or you can work as per your InfoSec security policies as well. So now I'm back in my resource group. I have external NSG. I can create my rule. I can add a rule, allow everything there. I will go ahead and show you how to allow everything. You just need to use that asterisk sign, give it a name. I will do the same for all the NSGs. So I will do it for NSG external and NSG internal, both on inbound direction as well as in outbound direction as well. So you can sit back and see all the steps. So I have included all the steps so that you are comfortable with all the components which we have used in this particular design. So now I am adding, allowing everything in my outbound rule for external NSG. I'll click OK. Same thing has to be done on internal NSG as well. So now let's go back to resource group and click refresh. Let's go back to internal NSG, which is now created. So I'll go into inbound rule, add a new rule. I will allow everything in NSG. So I have allowed everything in NSGs, starting from the internal NSGs and external NSGs, both in outbound and inbound direction. So this is a requirement from Azure that if you're using standard load balancer or standard IP addresses, you should explicitly allow traffic in NSG. By default, when NSG is not assigned to the interface, it is every traffic is allowed, all traffic is allowed on that interface. But the moment you use standard IPs, things will change. You need to assign NSG explicitly. So I have created NSGs, and this is how things will look like when you will create NSG. Now let's go back to resource group, and you have both NSGs there. Now next step is to deploy Windows machine. So in this demo, what I'm going to do is I'm going to deploy a Windows machine as well in my web subnet, and I want you at the end of the video, I want you to understand complete traffic flow. So this is why I'm deploying my Windows machine as well. So I'm going to use my resource group. I'll give it a name as WS01. I will fill all the required informations like username, password, and I will deploy it without any kind of availability set option. So I just have one web server, so I'm going to give it a name, IP address, and password. Once this server is deployed, remember, I will go ahead and log in using the public IP address first, because I will have to allow web services, or I will have to install IIS services. So I have allowed HTTP, HTTPS, SSH, and RDP connection to this particular machine, and I will go ahead and click next for disk. For this demo, I'm going to use standard SSD. I will click next now. Here in the public IP name, so I want to put this device in web subnet, so I'm going to use web. And later down in this demo, you will see that this VM will get IP address as 10.82.4.4, which is from internal subnet. I will leave all the options as default on this particular window, and I will click next. I will click next on this window as well, next on this window as well. Okay, review and create. So this will give you information about per hour billing and all. So if you want, you can read it and then click create. Creation of windows will take around 5 to 10 minutes. So I have added this Windows server just to show you how traffic will flow from outside to inside directly without coming through the firewall, because it will have public IP address directly on the interface. But if you want to send traffic through the device, you can use you can ask your users to hit front-end IP address on the external load balancer. An external load balancer will load balance it between the two firewalls, and your traffic will be active traffic. So this device is getting deployed now, and after it is deployed, I have skipped that particular part where I will log into this device and enable IIS services. So I'm assuming that you know how to enable IIS services on a Windows 2012 machine. So that part is not shown in this particular demo, but it's good that you can just deploy a machine and test end-to-end traffic flow. So Windows machine is now deployed and ready for use. Now next step is I will go ahead and initialize my firewalls. So if you log in to resource group again, you have to search for firewalls NGFW. So you will see firewall 1 and firewall 2. You just need to copy public IP address of each firewall and log in using SSH. So this 20.185.97.160 is public IP address of my firewall. I will use SSH connection. I'll use SSH admin and @ and IP address of the device. By default, when you log into your firewall for the first time, your default password is capital A, uppercase A, D, MIN 123. So admin 123 with uppercase A. So now once you will log in for the first time, it will ask you to change your password. You can add a new password here, confirm your password, and hit enter on all the default options. So you will say yes, no, manual, and then you will just hit enter on these options. While deploying the firewall using ARM templates, these informations were taken from the template. So these informations are this information is already on the next generation firewall, so you don't have to redo it. Now firewall is getting configured in the routed mode. Once it is up, you need to specify configure manager command. Configure manager command will show you is required on the next generation firewall, because we want to manage it using Firepower Management Center. So since my device is behind network a NAT device, I'm going to use, and FMC is behind NAT device, I'm going to use do not resolve, and then I will give key and then NAT ID. NAT ID is an arbitrary number. In this case I'm using 5, so I will be using same thing on FMC as well. Now I'm going inside my second firewall, a 20 185.99 185 is my second firewall. I'm going to connect to my second firewall in the same way. I will just SSH log into the device, and then I will use the same procedure by giving the new password. But default password when you log in first time, it is admin, ADMIN 123 with capital A, uppercase A. So now you need to add your new password, confirm your password, select default options for everything here. And since everything is now configured, what you need to do is you need to add same configure manager command on this device as well. Once so now both firewalls are initialized, there is no further work required on firewall. Now what you will do is you will go ahead and configure other settings. So I will talk about now registration of the firewall and access control policies, security zones, and interfaces. So these are three or four important configuration steps that you need to do. So this is my Firepower Management Center from where I'm managing my next generation firewalls. I will go to device management. I will hit add. I will give public IP address of my first firewall. I will give it a name, NGFWv01. I will give it a registration key as well, which I have used in my configure manager command. Now here I need to configure my access control policy as well. I will configure it. For this demo I'm just doing network discovery, which will just inspect traffic. It will not drop any traffic. So for the sake of simplicity, I'm going ahead with network discovery. I will enable malware, threat, URL filtering licenses, and I will give my NAT ID, which is just an arbitrary number that I have used in my configure manager command as well. So I'm going to use that same NAT ID here. So once firewall is added, I will go ahead and add my second firewall as well. So I'll just copy my IP address for the second firewall. This is the public IP address because my FMC is outside of Azure environment and I'm managing it over the internet. So I'm going to use public IP address of my second firewall as well. I will give my key. I will enable all the licenses. I'll give my NAT ID and click on register. So both firewalls are now getting registered. First firewall is already green, which means that it has registered successfully. Second firewall is still in the process of getting registered. In the meantime, I will go ahead and click edit on my first firewall. I will go ahead and first of all add configuration to my interfaces. So I need to use name for this interface, external. I need to enable this, and enable this interface. Before clicking IPv4, make sure that you click enable. Then I will create my security zone. So there is no security zone in FMC right now. I have created external zone, and the name of the interface is also external. I'm just giving IP address 2.10, which is IP address of this device. So you just need to ensure that you click enable before clicking OK. I accidentally, while recording the video, I was unable to do it, but later on, when during the troubleshooting phase, I enabled it. So now I'm on the second interface. I need to check that enabled page. I'm creating my second security zone, which is inside. Now I'm giving IP address to this particular interface, which is 10.82.3.10.12. Click OK. And now I need to save this configuration, and I'll go to device management, and I will do the same thing for second firewall as well. So here again, I will open my external interface, hit enable, select externals in external security zone, give it IP address 10.82.2.11/24. click OK. Same thing for second interface as well. (10.82.3.11/24). OK. I will then hit save, and I will hit deploy. Unless you deploy any configuration, that is not that configuration is not applied to firepower threat defense or next generation firewall. So ensure when you save configuration, go to deploy button and hit deploy to deploy that configuration on the firewall as well. So we have configured a firewall, we have our base infrastructure in Azure ready, our firewalls are initialized, interfaces are initialized. Now we will configure routes. Remember, when I was talking about deep dive of this scalable design, I talked about adding routes as well. So I will go to device management first, and then I will go to my first firewall. I will hit routing. I will create static routes. So first route that I'm going to create is for my subnet. So I'm going to create a route and point it to internal interface. I will create web application and database. So 4.0, 5.0 and 6.0. I will add all the three subnets in one route. So I'm going to make this configuration a little bit simpler by adding all the subnets in one route table. (10.82.6.0/24). click OK. And now I'm going to use metric, a different metric, because one metric is for the management subnet there. So I will go ahead and send it to the internal IP, which is 10.82.3.1, which is first IP address of my internal subnet, and that IP address is Azure Gateway, and I have used 3 as my metric. So I have clicked OK. So this is a return route for going back to all my subnets. Now I'm going to use external route IP any. So this is going to be a default route on this particular device, 10.82.2.1, which is first IP address of external subnet, and I'm going to use that IP address as the default gateway. Now I need to add routes for couple of more items. First one is going to be my firewall management interface, because I'm probing through the firewall, and when I probe through the firewall, I need to have route for my management interface. So I'm going to add a route. One time I will add this same destination using the outside interface, and other time I will use it for inside interface as well, but different metrics, because if there is no route available on the firewall is going to drop this traffic. So I need to send traffic through the firewall for inside and outside as well. So I have added external route. Now I'm adding internal route. When I say internal route, I'm referring to route pointing to internal interface. So now I will here again use MGMT management interface IP address of the first firewall. Now here I will use 10.82.3.1, which is first IP address of internal subnet metric 3. So I'm just using two routes. One route is going to outside, other route is going to inside. So now I will create a route for load balancer IP address as well. I will point it to inside. I will hit available networks, Azure IP. .168.63.129.16, and this IP address is IP address of Azure load balancer. So I'm going to create route for this IP as well. So again, one route will go to internal 10.82.3.1 and metric 3. Same route pointing to external interface with next hop 2.1. Why I'm doing it? Because I need to enable probes for my external and internal load balancer as well. So same kind of configuration is required on second firewall as well. So similar kind of routes will come there as well, but when I talk about management IP address on second firewall, instead of probing firewall 1 IP, I'm going to probe management IP address of firewall 2. So here routing, I will go to static routes. Internal route, this is going to be for all the subnets, web, app, and database. I'm pointing it to internal interface. I will send it to 10.82.3.1. again, this is first IP address of internal subnet, which is Azure gateway. So I'm going to deploy it. Next route is about default gateway. It's a default route, so I'm going to point it to 10.82.2.1, first IP address of external subnet with metric 2. I'll click OK. Add again. So here I will go ahead and now add, I will point to internal interface, and then in the available subnet I'm going to add firewall management 2 IP address, FW management MGMT02 10.82.0.11. So I am going to probe .11 when it is about second firewall. Management IP2, I'll just go ahead and add it. Next hop is going to be 10.82.3.1, first IP address of internal subnet again. So I just made an error here, so I'll just quickly in few minutes I will modify this route. I will just move to next route first, and then I'll come back to that route. External interface IP address 10.82.2.1 metric 2. Okay, I will then go back and modify this route here because that was accidentally added. I just accidentally used tab button here. I should have written the correct IP address, 1082.3.1. so I'll go ahead and click OK. I've just modified that route as well. Now I will go ahead and add route for Azure load balancer on my second firewall as well. So internal route and external route both will come here. If it is going to internal, next hop is going to be first IP address of internal subnet, which is 3.2 and metric 3. I'll click OK on this window. Similar route will come for outside interface as well. So external Azure load balancer IP 10.82.2.1 2, and then I will click save. So I have added all the required routes on my firewall 1 and firewall 2 as well. Now I will go ahead and click deploy. So I'm just verifying if I have used correct IP addresses or not, and once I'm satisfied, I will go ahead and click save, and I will then click on deploy, and I will deploy this configuration to both firewalls. So from here we just need to wait for a couple of seconds so that all the route configuration is pushed to both firewalls. So you can see that policies are getting deployed, your routes are getting deployed on both firewalls. And once these routes are deployed, we can then move to our next step, which is going to be configuring NAT statements. Okay, next step is to configure NAT policies on next generation firewall 01 and 02. So I'm going to create a NAT policy, threat defense NAT policy. Policy 1, and I'm going to apply this policy 1 on next generation firewall 1. Now remember when I talked about probes, I talked about different kind of NATs we need. First of all, I'll create an auto NAT, and I will create a dynamic auto NAT first with source internal and destination external. So this is a path statement which I'm creating for any traffic coming from internal subnet going to internet. That traffic is going to be pathed to my external interface IP address using this particular statement. So I'm saying anybody from inside going to outside, and if egress interface is outside or external, translate it to external interface IP address, and it's a dynamic auto NAT, dynamic NAT here. I'm going to create other kind of NAT statements as well. So next statement is a manual NAT statement. I'm going to use my interface name, so I will say outside or external to internal. Any traffic coming from outside, from external side to my internal network, and if it is a IP any, so anybody from outside to inside hitting my source interface, which is my external interface on port 80, then what I will do is I will translate that destination to egress interface. So any traffic coming from outside to inside, I will change source to inside interface. And now I will go back to my web server WS01. If I look at my web server, I just need to find IP address, internal IP address of that web server. I think it is going to be 1082.4.4. So I'll just quickly look at it. Okay, it is 4.4. I'm going to copy this IP address, and if anybody from internet hitting my external interface on port 80, that will go to my web server. So that is the policy that I'm creating, NAT policy. So anything on port 80 coming to my external interface will go to my web server, which is in internal subnet, and I will click port 80 or specify my destination port as port 80. And in the translated destination, I need to select my server as well. So I'll just click OK here. Okay, so here I just need to, from the drop down menu, I need to select my web server address. So I'm saying anything hitting on the external interface on port 80 will go to my internal interface, but on the way out, change source as my internal interface IP address. So that is the static translation that I have added for my web server, north-south communication. Now I will create NAT statements which are required for making the probes to work. So I will go to my statements, NAT statements again, external interface from internal to external, and I'm going to use original source as Azure load balancer. So any traffic coming from Azure load balancer on port 22 on my inside interface. So I'm creating this for internal load balancer. So any traffic coming hitting on the internal load balancer on port 22, translate destination to external interface IP address, and here I'm going to translate my destination as my management IP address, but I will keep that port as same, port 22. I'll click OK. Now I need to create reverse kind of NAT for this one as well. So first I have created external to internal, internal to external. Now I will do external to internal translation. So I will specify first, this translation is basically for making my internal load balancer probes to work. Now I will go ahead and add another translation which is going to be from external to internal for my external load balancer. So any traffic hitting any traffic coming from load balancer IP address on my source interface on port 22, I'm going to translate my IP address to destination interface address, and here I will specify management. I'm going to change my destination address to firewall 1 management interface. I will click OK. Okay, so now I have all the required config on the NAT side. I will click save, and then I will go back to NAT statements again, and I will click add NAT policy again. I will create another policy for my second firewall. So similar kind of NAT is required, only difference is you need to have management to IP address rather than firewall management 1 address. So first translation again is going to be auto NAT, dynamic NAT from inside to outside for any traffic going outbound, from any source, and destination is my destination subnet. Destination translation is on the destination subnet. Now I will create NATs for my web server. So again, here my web server is external to internal, any source is any. So any traffic hitting on my external interface is going to be translated to my source interface. Any traffic hitting on the source interface on port 80, I will translate source to my destination interface, which is inside interface. In this case, I will change my destination address to the web server, which is there in the web subnet, and I will use port 80. Now I need to create NATs for my management IP, because that NAT is being used by firewall for enabling probe traffic. So this is a kind of a probe mechanism, so where you require a little bit more configuration, because you are testing complete firewall stack. So traffic will come from one side of the interface and it will leave the other side. So it requires a lot of manual that configuration. But if you are planning to probe firewalls by just probing the interface, you just need to enable one setting in platform settings of your firepower management center that will enable SSH on that interface, and you can just probe that particular interface. Or if you are planning to probe your web traffic or application traffic probe as well, you just need one translation for that particular server. As it is, you require it because you are accessing it from outside. You will just use same NAT statement for probing your web server as well. So that is how you will do it. So I'm not talking about these translations because it is exactly the same thing that you have deployed in the previous slide on the previous NAT translation for firewall 1. Same kind of translation you are doing on firewall 2 as well. So instead of firewall 1's management IP address, here I'm using firewall 2 management IP address. Okay, so nothing really different. So I'll just click save now, and I will click deploy. So once these NAT statements are deployed on the firewall, we have complete configuration on the firewall to enable probe traffic. So you have your NAT policies, you have your interface configuration, you have your route configs, you have your access control policy, and you have your network security groups in place as well. So once you have all the things enabled, your load balancers are already sending probe traffic. The moment you have your firewall configured, your probes will come up. So we'll see that in a couple of minutes, where I will show you how to check whether probes are up or not. Now let's go ahead and verify probes on internal load balancer and external load balancer. Now let's go back to our resource group. In our resource group, I'll look for external load balancer. I'll go to metrics, and I will change from 24 hours to last 30 minutes, and I will click apply. I will here use health probe status from this drop down menu, and if you look at this status now, this status is up. Okay, so our firewalls are now up. So our external interface, external load balancer, is able to probe through the firewall. Now let's look at internal load balancer as well. So I have internal load balancer now. I'll go to the same place, metrics. I will click health probe status, and then I will click last 30 minutes instead of 24 hours. Now you will see that our probes for internal load balancers are also up. So internal load balancer is able to probe management interface. So through the firewall, probes are working fine. Both firewalls are showing as healthy. So what we need to do now is we need to go to our internal load balancer, and if you can see our web server. This is our web server's public IP address. Let's look at our web server's public IP address. I have copied this IP here, and you can RDP your web server, apply your application configuration, and if you look at this private IP address here, it is 10.82.4.4. so the web server is up and running, and it is in the network. Now let's point our UDRs. Before pointing these UDRs, I went ahead and added my IIS services using the public route, and I've just added that information, rebooted my server. Once that server is up, now I'm configuring my UDRs. So I'll go to route tables. I will create a route table, web-UDR, and I will give it a name and point it to my resource group, and I will click create. Once it is created, it is going to take around 1 or 2 minutes to create a route table. Once route table is created, you can go inside that route table and add your routes. So we'll wait and we'll go back to our resource group. Now here I will look for UDR. Now here in this UDR, if you look at routes, there is no route available. So I'll just first of all click on this particular UDR and I will show you configuration inside this UDR. Okay, so I will show you there is no route available. I'm going to add a default route. So default route is going to point to 10.82.3.100. Okay, I have a default route, and from this drop down menu I just need to use virtual appliance because I'm using IP address of my internal load balancer as next hop. So I will use virtual appliance and I will point it to that particular IP address, and 3.100 is IP address of my load balancer. Now I'm associating my route table, so I'm going to pick up my virtual network, and there I need to use my web server. I will click OK. Now my route is getting route table is getting associated. Like in the same way, I need to create route table for my application subnet, route table for my database subnet as well, and similarly I will create default route and I will associate it. So now if you look at this particular network, what we have done till this point is we have deployed firewalls, we have added subnets, we have added route tables, we have created internal load balancer, external load balancer. External load balancer has a public IP address, which is a front-end IP address, and users will go there. And behind my firewall, I have a web subnet where I have my web server located or created. So intention is to access that application server through the firewall, through the load balancers. So till this point I have all my route tables in place. I have associated my route tables to the correct subnets, and I'm pointing my route table to virtual IP address of internal load balancer. And on the external side, my firewalls are properly probing my management interfaces. So I have complete setup now. So you can imagine that I have 2 firewalls right now, but you can add more firewalls in the same way. You can add multiple firewalls as and when required. You can add more firewalls to your network. So now I'm on to the last UDR, which is my database UDR. I'm adding that route table as well. So once that route is created, I will associate it to my database subnet as well. But in this demo, I'm not showing you east-west traffic. It is just a matter of placing another server in database or application subnet, and UDRs are in place. So if you have everything in place, everything should work fine. There should not be any problem. You might have to add one more route in your route table for the destination subnet. So take it as an assignment. When you create your network, go ahead and add those routes and send traffic to firewall for east-west. But in this video we are focused on north-south traffic coming from outside. East-west traffic inspection is again the same thing. You just need to add another route. If you are in your web route table, you need to add route for application subnet and your database subnet and point it to the same IP 3.100, which is again your virtual IP address. So now I'm associating my database subnet route table to my database subnet. So our base infrastructure is ready, and I guess we are ready for testing a couple of things. But before that, let me tell you again. So route tables are in place, firewalls are in place, our access control policy, NAT, route, everything is configured on all the devices. So everything seems to be correctly configured till this particular point. Now let's tweak firewall access control policy to log new connections. Okay, so I will go to my access control policy, and I will quickly go ahead and create a policy that allows everything, and at the end I will also click on logging to log all the traffic. So I will go inside the policy, I will click on add rule. Here I will say allow all. I will click on the tab which says login there, logging, and I will log beginning and end of the session or connection. I will click OK, then I will click save, and I will deploy it to the firewalls. So I'm going to deploy this policy to both firewalls. Reason of adding this logging information is when I will send traffic from outside, I need to see that in my events. So I have added that information now, and I will now go ahead and find out my front-end IP address from load balancer. So I'm back in my resource group. I'm searching for external load balancer, and let's go ahead and look for front-end IP configuration. This is my front-end IP. I can now look at the connection table. I've initiated a connection and it went through. So I'm now looking at my connection table here, and events in my Firepower Management Center, and you can see that I was able to access my web server using a front-end IP, and you can see that traffic is going to 10.82.4.4. So if you look at right inside topmost corner on my browser tab, you will see that I was able to open my IIS server. So that part of the connection is working fine. Now let's do a device failure test. So when I say device failure test, I will just show you multiple connections. I'm using front-end IP address. I'm not using public IP address of my server. So I'm going very fast. I'm going and accessing my servers, and I will show you that I'm just using another browser or incognito mode as well. So I'm just trying and accessing all my web servers using my front-end address. Now what I will do is I will log into the firewall, and I have applied captures. You will see that both firewalls are processing traffic, and I will do a show capture on both firewalls, firewall 1 and firewall 2. You will see that both firewalls are actively passing traffic. So now I'm now going ahead and switching off firewall 1. So just to show you a device failure scenario as well. So I'll go ahead and stop this firewall. Ideally this is not the correct way to stop firewall. I should have gone inside Firepower Management Center and powered it off, but I'm going to show you a device failure scenario. So I have just went ahead and abruptly powered off my first firewall. Even when this firewall is off, I should be able to access my application servers because my second firewall is still alive. So you can see that first firewall is out of service now. It has been rebooted. I will go and clear capture on my second firewall, and I will show you that I still have my network connectivity. So I'll go ahead and show you captures now. Now I'm accessing my server again. I'm able to hit my server again. Okay, the moment I've switched off my firewall, load balancer kicked out that firewall based on the timers or interval of probes. So I can now see that traffic is still making through, and it is going through my second firewall, so my network is not down. I can simply turn on that firewall. Once it will come back up, once we have proper probes again, it will work fine. It will be added back to the cluster, back to the backend pool, and it will work. So this is what we have deployed, multiple firewalls with multiple load balancer. In this demo, I've created everything from scratch, starting from resource group, availability set, virtual network, subnet, and all the other components which is required in order to make this particular thing. Important part is NAT, route, and UDR configuration. So everything is being done. So I hope you enjoyed this long demo. Thank you for watching.